And I'm having some difficulty with the essay questions. When I grade it, it still doesn't count it as graded. So I might, if I can, delete all of those three. I think there were three essay questions that required a written response, because I'm grading them and okay, I'm grading them and it's still coming up not graded. So rather than go through all of that, there were 48 questions. I think taking out three isn't going to make that big a deal. So I will do that. Take those if I can. I will take those out. All right, Deborah, let me check on Isadora. I see your message. So yes, do that. All right, so you just let's use the first 10 minutes to do if you need to catch up on something or read that um, page in Canvas. Let's do that, and then I'm going to pull up the video for that. Okay. Assignments. All right. Also, if you haven't done the in the AP Classroom, 4.1 has also been assigned in the AP Classroom. Let's see. All right, good afternoon. All right, good afternoon. If you just joined, we are in 4.1 plate tectonics in Canvas for the next few minutes. Okay, let me see if I can try this a different way. Um, Maybe I can just assign it to you. Let's see it. Here we go. All right, dictate. Okay. All right. Gosh, this thing is so hard to change. Okay, Deborah, I think I got the due date changed, so it should give me a minute to update it. So many things to click on. All right, Deborah, try it again. Try to access it again and see if it'll let you, and it shouldn't be locked. It had a due date of the 31st of January, that's why. But try it again, please, and let me know what happens. Okay, that's not what I want. Okay, good. Excellent, excellent. $22 and $39. All right, I'm going to Okay, progress reports are going out this week. Everybody who's present today is current, so not to worry. So thank you for that. If you have anything outstanding, all right, that worked. Okay, that worked. I took out all those questions that were difficult to grade, and now it is graded, everybody. So you should be able to see a score for this now. Okay. Okay, and Deborah, I see yours is in progress. And why does this one say submitted? No, they should have been omitted. So if they're still there, don't do them. They should have been deleted. So now the total number of questions should be 43. So I deleted some questions. So don't do those. Mm, that's all I had to do. Okay, now I have to fix the three that I already looked at. Because now it won't grade those. Okay. All right, in about 5 minutes, I'm going to show the video that I have for you. Uh, Sometimes this site is not user-friendly. All right, I'm going to do this. It's having a problem. We'll come back and look at that later. And I am just going to work with okay, so I'm going to go ahead and show the video that I had for you. Take a break from whatever it is you're doing and focus your attention on the video.
Which is plate tectonics. So we'll start off our coverage of Unit 4 here by talking about the fact that, believe it or not, the entire world we see and experience, the land, the oceans, it's all just a really thin layer of rock floating on an ocean of magma. So this thin little rock layer that we live on is called the lithosphere, and it's broken up into chunks called tectonic plates. So we have a mountain in the background here because tectonic plates colliding is actually what creates mountains. So in today's video, we'll be covering how mountains are formed, along with all the other geological formations that can be caused by tectonic activity. So our objective for the day is to be able to describe the geological changes and events that occur at plate boundaries. In order to do that, we need to know that there are 3 plate boundary types. Those are convergent, divergent, and transform fault boundaries. We'll also learn what types of events and landforms each of these can produce. And then finally, we'll learn that earthquakes occur when the stress overcomes a locked or a stuck fault, which releases tons of energy. Our suggested science skill for today is explaining how visual representations of environmental concepts relate to environmental issues. We'll be looking at some diagrams of different plate boundary types, as well as a map of global plate boundaries to practice this. So before we talk about plate tectonic activity, we just have to get down some basic definitions of Earth's different layers here. So at the very center of Earth, we have the core. This is a dense mass of solid nickel and iron, but it has radioactive elements as well that are going to release massive amounts of heat. So all of this heat that's released from Earth's inner core turns the next layer around it, the mantle, into a sea of magma. And it's this super hot magma that's going to drive the movement of the lithosphere plates above it, which is the basis of tectonic plate activity. If we look outside of the mantle, we'll see this very thin layer called the asthenosphere. This is a semi-solid rock layer that exists on top of the mantle. And then the layer that we'll be focused on today is the lithosphere. So this is the very thin, brittle rock layer that's Earth's outermost layer. That's the layer that's broken into the tectonic plates that we'll be talking about. And then on the very top of the lithosphere, we have the crust. And this is where soil, plants, organisms live. This is where all of life on Earth exists.
It's lovely where these all have commercials all the time.
Build custom industrial machines in days.
Now we'll talk about the three different types of plate boundaries. So the first type of plate boundary is a divergent plate boundary. This is where plates are moving away from each other. And they're doing this because of heated magma from the mantle that's rising up towards the surface and pushing the plates apart. And so you can use this hand motion to remember that the magma is rising up from the mantle, and then it forces the plates apart to diverge. This is going to form mid-oceanic ridges, which you can think of as underground mountain ranges. It's also going to form volcanoes, seafloor spreading, and on land it can form something called a rift valley. Now we have convergent plate boundaries. To converge means to come together. So these are plate boundaries that are colliding or moving towards one another. And we can use this hand motion to remember that when they come together, one of them gets subducted or forced underneath another plate. So we can see in the diagram here, when they collide, one plate is forced down beneath the other, and that's called subduction. This leads to the formations of mountains, island arcs, earthquakes, and volcanoes. And then the last type of plate boundary we have to talk about is a transform fault boundary. If we look at the diagram here, we'll see that this is when two plates are moving alongside each other in opposite directions. We can use this hand motion to symbolize the transform fault boundary, but the problem is that when they try to slide past each other, they sometimes become stuck or locked. They keep trying to move past each other, which builds up a lot of stress, and when that stress is overcome, they release suddenly, which gives off a ton of energy, and that's an earthquake. Next, we're going to talk about something called convection cycles. So convection cycles are cycles of heating and cooling magma that rises up to the surface of the lithosphere, cools and expands, spreads out along the surface of the lithosphere, and then sinks back down in the mantle to repeat the process again. So if we look at this diagram here, the center point where the magma is rising is called a hot spot. This is where the magma is super hot, and so as it rises, it actually melts the edges of these plate boundaries and forces them apart, which creates this divergent boundary. If we look at the diagram, we'll see this ridge that extends at the plate boundary, and this is called a mid-oceanic ridge, because when the magma hits the lithosphere, it actually forces it upward a little bit, forming a ridge. Now, if the magma rises with enough force, it can actually force its way through the lithosphere, causing a volcano. Then when that volcano cools, what's left is an island. And so we can see this on the map at the end of the video. We'll have some islands that appear in the middle of the ocean, and oftentimes these can be formed at divergent plate boundaries. It's also important to note that this magma, when it meets the lithosphere here, it cools and forms new lithosphere to replace the plates that it's pushing apart. It also continues to cool and spread below the surface of the lithosphere, which pulls the oceanic plates apart and eventually causes them to run into continental and other oceanic plates, forming subduction zones. Because the oceanic plate is more dense, it sinks or subducts beneath the continental plate, melts, and turns back into magma to complete the convection cycle all over again. But the pressure of this oceanic plate pushing its way underneath the continental plate can also force magma underneath the continental plate up to the surface. This can create a volcano on land and can also lead to narrow coastal mountain ranges such as the Andes in South America. So now
Another commercial.
Work today is broken. We're all working in too many disconnected apps, and it's killing team productivity.
So now we'll talk about convergent plate boundaries, which cause subduction or the sliding of one plate underneath another. So it's important to know that this can happen between any two types of plates, and we'll talk about how landforms and events occur at each example. So when two oceanic plates collide on the left here, one will subduct beneath the other, and this forces magma up to the lithosphere, which forms volcanoes. Because this magma continually rises up to the surface in the same spot, but the plate above it is shifting, each time it erupts, it makes a new island, which is what gives us island arcs such as Japan, Indonesia. It can also form offshore trenches when the margin of one oceanic plate is pulled down beneath the other. When an oceanic plate collides with a continental plate, the oceanic plate is subducted beneath the continental plate because it's more dense. So the oceanic plate melts back into magma in the mantle, but it also forces submagma up toward the surface of the lithosphere, leading to volcanoes, but this time on land. This can also create narrow coastal mountain ranges like the Andes in South America. We can also see trenches and tsunamis formed at convergent plate boundaries, and we'll be exploring tsunami formation in more detail in class. Finally, we have continental-continental plate collisions, which subduct one plate beneath the other, but also push some of the crust upward, which forms large mid-continental mountain ranges like the Himalayas. At a transform plate boundary, we have two plates sliding past each other in opposite directions, which creates a fault or a fracture in the surface of the lithosphere. Earthquakes occur primarily at transform fault boundaries because the jagged edges of the two plates get caught on each other and they become stuck or locked. So as the two plates are trying to slide past one another, their edges are rough so they catch and they essentially become locked. The edges of these plates remain locked together even though the plates themselves are moving in opposite directions. So what happens is this builds up tremendous pressure over time. And when the stress pulling the plates in opposite directions overcomes that locked fault, the plates will suddenly slip free at once. And that will release a tremendous amount of energy and send shock waves throughout the ground. So we can see these waves spreading throughout the ground in this lower diagram, and that's going to cause the earth nearby to shake violently, and that's what an earthquake is. And finally, the last thing we'll be talking about today is how this map of tectonic plate boundaries can help us predict the locations of everything from earthquakes and volcanoes to new islands forming. So first we'll be looking at something called the Ring of Fire. The Ring of Fire is this pattern of volcanoes here that we see all around the Pacific Plate. The reason we see volcanoes here is because these are all areas where we have convergent zones. So what that means is this more dense Pacific Plate is converging with and subducting beneath the continental plate. What that does is forces magma up to the surface on the continental plate, which leads to these volcanoes in this predictable pattern. So again, we call it the Ring of Fire because it's a ring of volcanoes all around the Pacific Plate where we have a convergent plate boundary. That's very important to remember. Convergent plate boundaries are primarily the ones that lead to this volcanic activity. Then we can see in orange, we have transform faults. So transform faults, remember, are the most likely locations of earthquakes to occur. So if we look at the coast of California, somewhere that we know receives a lot of earthquakes, we'll see it lies right along a transform fault boundary. We can also look at Haiti. Haiti lies right along the transform fault boundary between the North American plate and the Caribbean plate. And this is why we know that there's also going to be a lot of earthquake activity in Haiti, who in 2010 suffered one of the worst earthquakes in recent history. And finally, if we look at the white, we'll see the divergent plate boundaries. This is where we're going to see mid-oceanic ridges, seafloor spreading, and potentially even volcanoes when the magma is rising up between those plates and cooling to form islands. In this case, we have Iceland here, but we can even see hot spots that are not necessarily associated with a plate boundary, where we have volcanic activity creating chains of islands just due to that same hotspot constantly shooting magma up through the lithosphere. In this case, that would be Hawaii right here. All right, everybody, our practice FRQ skill for today is explaining how environmental concepts and processes relate to broader environmental issues by using visual diagrams. So think about the visual diagrams from today and try to use them to explain how subduction leads to volcanic activity. All right, everybody, thanks for tuning in today. Don't forget to like this video if it was helpful.
All right, so those questions should be in the AP classroom as well. They should be the same questions that have been assigned in the AP classroom. So just make sure that you have answered those assigned topic questions in the AP classroom, as well as, now some of this, if you had um, physical science. You've probably talked about this and it's probably been a minute, so you probably might not remember everything. You might vaguely remember talking about plate tectonics and the Pangea, where we were all one continent and then it split apart like puzzle pieces. So hopefully a little bit of that came back to you if you had that in the other grades. But definitely you need to know the different type of plate boundaries. You need to know the difference between those that are continent to continent, continent to ocean, and then what is happening in the middle of the ocean. And again, I'm sure that was a refresher, I hope, on the layers of the Earth. They might not have always used the terms asthenosphere and lithosphere, but those terms you do need to be familiar with. So what I also recommend is that you go back and look at, I'm a strong believer in vocabulary can help you answer any questions, especially with the AP exams. They're looking for you to use the vocabulary. They are um, um, this is not going to open up, is it? They're looking for you to use the vocabulary when answering the questions and not just give a vague answer to the question. The questions that I took off of the other one, I may pull those at a later date and just give a like a midterm exam where you look at those kind of questions. I just took them off because it was not allowing the test to grade with those in there. No matter what I did to it, it would still give a yellow signal and keep the test unscored. So I took those questions out so the test would score. So again, use the rest of this time to make sure that you have read over. Let's look at this while we're here. 16. No, we don't have time to look at that because it's 16 minutes long, but make sure you've looked at
Hey
this one.
everyone, I just wanted to
Make sure you look at that one. That's kind of a preview because the whole unit is it's like an earth science um, unit. We're going to talk about layers of soil. Again, I might try to go through this one kind of quickly because I feel like you've been through this before. Tell me yes or no if you haven't. Type in the chat. Are you familiar with the topics that are listed here? Because if so, I can go through this one quickly and move on to the next one. Because like I said, we have a lot to cover. Yes, okay. That's what I thought. Okay, good. All right, well, let me put it this way. Is this unfamiliar to anybody? I don't want to skip over the whole unit, but I want to go through, kind of breeze through it a little quickly so that we could get to the next one. These last two topics I may do module familiar. Okay. So I'll give a brief overview of the first set and then actually spend some time with module 10 and 11. Those are contemporary. And I always try to keep it contemporary as well. Georgia may not be on a fault line, but we have had some earthquakes. So we get mild earthquakes every once in a while, nothing like California, but there is a slight, small fault line that goes between, I think, Georgia and Tennessee. Let me look that up real quick. But I have felt the earthquake. It usually happens in the middle, and early in the morning, but I have felt an earthquake here in Georgia. Okay. And I forget that there is actually a fault line. Let me type that in. Okay, I got a map that kind of shows you one that's close to us. All right, so if we look at this map, there is this line, the black line that goes through the top of Georgia. So Atlanta, you may not feel it because you're down here a little more South Georgia, but being as Atlanta is almost North Georgia, and that's where I am. So I'm able to feel it, but you probably, and they're so slight that you probably would never feel it. But there is a fault line that goes through Georgia. Okay, so that's just FYI. There's not going to be a question that will ask you that. All right. So again, with the time that's left, just make sure that you are up to date on all of your AP classroom assignments. I'm going to get those scores in the grade book. And if you have nothing for me, you're good to go. And I'll see you tomorrow.